And I hope if you have Linux or Ubuntu, you should have prepared more for conference like me, and especially if you do some talk in a cinema. So lucky you, you have a 3D version of me, and you don't need to put your glasses on to see this 3D. But I will say have some 2D stuff. It's my slides out there, and yeah, with myself, there was no problem to display it, but with slides, it's always a problem. So I'm from conception team. I've been developing conception, and I've started to work as a tech consultant. So the story was that one German company approached me and said to me, "Hey, you developed conception, come to us to Berlin, you will consult us." And my first thought that my software was so complicated, so shitty, they just couldn't understand how to make it running. But then they said, no, you will be tech consultant on the working platform. We installed actually conception, we use it, but we don't know how to start writing tests, what to test and how to design our test architecture. And my first thought was, well, I'm just writing a code, just developing a testing framework. I don't know how to build your test architecture, really. But they insisted and said, yeah, you're a testing guy, just come here. And I think most of stuff I'll tell today, it's experience I learned by working in that company, by solving their problems. And after the 2 weeks, I really felt myself like a tech consultant more than a coder. So the testing is not just about installing conception or PHP unit and writing some tests. The testing is sometimes more about writing good tests, yeah? So making this efficient, fun, and that business understood actually why do you spend your time on this. So at first, if we think of testing, we need to think how to make business to understand what we are doing. And let's put some business word in testing together. And from this mindset, we will try to discover what tests are and why should business care about them. So why do we test? We test at first to ensure that our software works as we designed it, to find some new bugs in our software, and for performance and for security stuff. So yeah, for some of this stuff, there are already professions like QA engineers, security engineers, and so on and so on. But as a developers, we can focus on solving only the first. Probably the third one can be solved by us too, but in this talk, I'll be focusing only on solving this first problem. So making sure that whatever we did in our software yesterday didn't break the stuff that was working before. So we ensure that our software works and we have automated tests to execute them at any time we need, and they will prove that software didn't change. So that's why we do automated testing. So we do it to trust more in our software. We do it for cases where we introduce lots of changes in our code base, and to make sure that new changes won't break the previous changes. And oh, some pictures didn't load. So but the problem with testing is that it's always about how to start writing tests. It starts with very simple examples like create a test for a simple class, and then probably one day you will discover how to do testing in general. But what we always forgot to talk about is what to test first. It's so I think the anti-pattern here is to figuring out parts that we can test and then testing them. We should figure out this stuff we need to test and focus on them, because they will probably bring us more value. So we need to discover what priority first scenarios we need to work on. And yeah, it's apparently something which is dealt with the business. And what is important for business, that's important to be tested. If it is e-commerce product, checkout process, login process, selecting. So all of this stuff is important. If it's especially something which deals with real money, discounts probably, they are really hard to test manually. So they should be automatically tested. And so all the business scenarios which are hard to test manually, which should be work all the time, they should be automated. And when we write tests, we need to design them to be atomic, so they should be focused around only one feature specific, and they should be independent. So the reason is that tests should be focused around the features, and if a feature changes, we should be ready to update the test and not to break other tests in a group. And when we start to think about what business feature we need to cover with tests first, we need to sit down with our business managers, with our QAs, and start writing down these test scenarios. You probably know this is Gherkin syntax from Behat, but I am not talking about Behat or Gherkin or BDD at all. I am talking about you need to start writing down these scenarios of what are important in your software. And start with very general words. Registration is important scenario. So what we do, what we want to achieve. But this scenario is so general that we don't have any, it doesn't have any meaning. So next step would be to introduce some more details into this scenario. So when we have scenario like this, we at least have some understanding of what we're testing and what should be checked. So this like our first test written on paper, and it's not automated yet. It's just a test scenario. So when we created the first draft of our test, we need to think what should our tests be. So our test should be pretty simple and readable. So this one was simple, readable, and it's easy to understand. But readability is can be broken if we implement this test in proper way. If we do this registration test as a unit test, probably we will break the readability. So tests should be easy to read, and especially when a new developer comes to a project, they should catch up with all this tests. If this developer changes something in the registration process, this developer should be able to update the test so it would pass the new requirements. And this code base would be as maintainable as your main code base. So do the code right. So as it was pointed that we can really break our readability if we do improper implementation of our test scenarios. So remember these registration scenarios. It was pretty simple in first, but if we try to implement as a test for unit test for controller, we get this deep mess of something, and actually we don't understand what happens here. So I think we should read this test from the bottom to understand that what is checking, and we still don't have any idea of why do we test it, what's the business purpose solved here, or I don't know, lots of stuff happening here. So just to mention that this test overuses mocks, and it can be easily broken with some external changes. Second is about stability, which I also wanted to point out that tests should be also stable to change to external changes in our system. They should be stable to execution, and they should be focused on the result and not on the path. So if the previous test was unstable to code changes, because if we change some parts in our code, the mocks will be broken. Some our web tests will be can be as fragile but on executions. Some pages won't be rendered as fast as we expected. Some elements are not located because the HTML design of page has changed. So there are lots of different ways to write unstable tests, and it's really hard to, like this one, yeah. It's really hard to understand how to make tests stable. So at first, let's don't put into our test concerns that are not really important to our business. So in this case, we are mocking the client class and expects that some method of this class is called only once. If it will be called 2 times, will it be a problem for us? Really? Is it so? So we are also using some hard-coded method names. So when we change something in our code base, PHP Storm is smart enough to handle this refactory all our code base to this change, but it won't be able to handle this because it's hard-coded method name in a mock. So by writing these 3 lines, we made our test very fragile and completely separated from our business and from our code base. It's unstable test. And so how can we work to write our stable tests? So again, let's go back to the scenarios we prepared and think about that scenario was a specification. So how it should work is a specification. How it actually works is implementation. And if we separate all these things, we can probably have ideas that we should stick to this, to the initial idea and not to the implementation. So we should focus on achieve the result and not the path we are achieving it. So as an example, if let's say there is a old style dad and he says to his son, we need a table. So let's grab a nails, a hammer, some wood, and let's build a table. So let me show how to do it right. And after like 10 minutes, son saying to the dad, it's really good table you are doing, but I already ordered a new one in IKEA. So buying a table in IKEA is much more effective way of doing stuff than doing it by itself. And if we have our test to be specified, like inject me nails, inject me hammer, inject me wood, and then do some stuff, it will be completely broken because we found a new, more effective way to achieve the same results. So in our test, we should also focus on the result, because our software can be changed, library may be changed, and we can always find a new, better way to do the same. So also we should focus on public interfaces. And when we say about interfaces, we have lots of stuff we're thinking of. So interface is a keyword in PHP. Interface is something we see in a browser. Interface is, I don't know, it's like a very, very general term, a REST API interface. So, and if what is common for all those interfaces? The interface is something that dictates us how can we work with the system. So it's like a general rule which shows us to work with the system. So the steering wheel in a car is interfaced to operating with the car, yeah? And if we see that on the carousel, kids are riding in the cabins, and they have also steering wheel. But they cannot change the direction with that steering wheel, but still they use that steering wheel. And when they grow older and they come to that car and they buy their own car and they are driving, they already got used to this interface. So interface is something that should not be changed from in time. So if in the future we'll have automatic driving vehicles, and they will probably still have the steering wheels just for people to be common to work with them, to be used to them. And generally speaking, interface is something we should avoid to change very regularly, because people feel very bad when they just open a website which was working yesterday, and they don't see the buttons on their used place, and they need to learn how to work with it again. And it's always a pain. So same with the code. If we refactor the code in very heavy way and removed lots of classes, interfaces, and so on, we will probably feel really bad with ourselves to discover how to do things in a new way. So that's again why we need interfaces. So interfaces should be something constant, something unchangeable in our very dynamic world. So again, about how to not making noisy and messy tests. Don't do over assumptions. Don't put too much technical details in our tests. And yeah, I took these ideas from the blog post about testing ground components just to show you that the ideas of testing are the same everywhere. So it's not about PHP or JS. So it's just what people learned in this. And the third quality of a test is a speed. So some unit testing evangelists say that this is the most important test quality. So you need to write lots of unit tests because they are very fast and they provide you with a really fast feedback. But to me, it makes no sense if those tests are unreadable and unstable. So what we actually want to achieve with a fast test, we want to write some code, execute tests, and get a fast feedback. So to see, did we break on the system now or not? And actually, for most cases, 20 seconds is enough to be considered fast feedback for us. And probably if we change one component, we want to test only that component for if it's broken or not. And if we want to check all the system, we create a pull request, and then all our system is tested on continuous integration server. And I don't know, it can take 10 minutes, 20 minutes, maybe an hour, but in the end, we will still get the result. So tests should be fast enough to provide us feedback on the components we are working, and fast enough to provide us full details when we try to move our code to the master branch. And yeah, if we do the CI testing, we can run our tests in parallel, so we can achieve this 20 minutes. And 20 minutes for the final results is fast enough. So if we change our code in one component and it broke another component, we will discover this by CI. And if it will be broken, okay, we will fix it. So speed is more about your personal comfort. And getting about back to the testing, I didn't tell about unit tests, about functional tests, about or maybe acceptance tests. I'm trying to convince you to think about these scenarios. And next is to think how can you test the same feature with a minimal effort. And now we will talk about how the tests can be implemented, because we have different options, not just unit tests. And we can test our system from different sides, from different perspectives, from internal and from outer. So in our case, our outer testing will we'll use a browser because we are building websites, or maybe if you are building REST APIs, it's curl client. But anyway, let's assume we have we can test the same feature from a browser like registration. We can open a page, register user, go step by step how user sees it, or we can do it internally by calling the same methods from the code. And we have different levels of doing that. So browser-based, curl-based from the outer scope, and functional testing from emulating the requests to the application, parsing responses, and so on. So on, integration testing and unit testing. So now, at least when we have designed our scenario to be executed, we need to figure out at which level it would be the most effective to be written. So effective from the readability, stability, and speed. Yeah. So there are different pros and cons about all those levels, and I think I won't get into all the details about these levels because I'm running out of time. But still, you need to consider which level is suitable for you. There is nothing like perfect layer to write all your tests on. So there are problems with any of them, and they are just different. So when we design our test architecture, we actually get to the moment where we understand that we can write the same test on any level, on acceptance level, on unit testing level, on integration testing level, and we may find ourselves duplicating the tests on them. And that diagram shows how to avoid it. Let's go deep to the, let's make tests which are more detailed ones on an internal level, on a domain, and focus on the one but happy path scenario on outer level. So we start with a general, and we go to the adding more details. So like filling up a form. Let's test on our front end that the form can be submitted and user sees the message the form was sent. Then on functional level, let's test what if a form was invalid. And on integration or unit test, let's check different invalidation errors of that form. And when we sum up, we have everything about this form tested, and tested in an effective way. So the acceptance test, which will have only one, will be pretty fast. And we have all the unit testing, which so we delegate all the validation checks from acceptance testing to unit level, and they're playing nice together. So that's what brings us to this like three very important points. You need to first to think about what to test, then add some examples and how you how the scenario is going, and then choose the most suitable testing layer to work with. And yeah, the more examples we add, the more edge case scenario we are putting, we will need to go to the most deeper layer, like unit or integration. And here are some basic ideas on how to start testing. So for new fancy project, we doesn't have any legacy code, we didn't spoil it yet. We should focus on our domain. So probably nowadays we have separate folder or separate namespace for everything which handles our domain logic. It's our service layer or domain layer, you know. And we should start with integration or unit testing this layer first. Then we need functional testing to make sure that uh, controllers actually operate correctly with this domain layer. And acceptance testing for very simple cases, for only happy paths, where we check that, yeah, system works not only from inside, but our users actually can operate with it too. And the very interesting type of a new project is a startup. In startup, we don't have a domain logic yet. And this is, the startup is kind of project, is a project where we don't have any interfaces from scratch. Because we are still unsure what we are doing. And developing startups through the TDD perspective is very, very bad idea, or BDD, because yeah, we can write all tests before the code, but probably we will rewrite all this code tomorrow, and that won't make any sense. So for startups project, a very agile project with constant iterations, I recommend to postpone testing to the time where you establish some stability in your code base. At one time, you'll probably get a REST API. REST API changes very rarely. So maybe REST API would be the good starting point for you to start testing. Then your designer comes up with some already good screens which you won't change in the future. So you can work on this as an interface. Then you find out that domain logic is clean enough and working good, so you can use it. And so when you establish trust in your code base, on your interface more and more, put your tests on them and not just do testing for the sake of a testing. And another type of a project is legacy. So in legacy, we start from the outer testing. We always need to start from the outer testing because we don't want to look into its code on any purpose. We just don't want to deal with their code. We better to spend more time writing the browser tests and playing with Selenium than looking into their shitty code because it's traumatic. So we try to cover as much scenarios with browser testing. And then we start, when we have all the scenarios tested and when we see the test passes, we can start slowly, step by step, refactoring our code bases, introducing new code pieces with unit tests on it, and moving the system to the new state. So how about using data management in our tests? So we have like 3 strategies to deal with the data. The most simple one is to create new records per each test and to make it so that they would be unique whenever the test is executed. We can clean up database between tests. It's a very naive, simple, and slowest approach. And we can create data for the test purpose and reward it afterwards. So these strategies you should be considered when you are writing all your tests except unit. Yeah, so when we discovered that we can write our tests on all those levels, we can probably find out that all of tests can be written on unit level and on integration level. So, and I've seen that some projects have those tests repeating themselves because, yeah, because they are testing the same scenarios, and we are really hard to understand which test should be more prioritized. And actually, unit tests are pretty hard to maintain, especially because of the examples I showed you before, and because of the dependencies, and if the dependencies are not interfaces, they are really fragile to code changes. So unit tests work very good for this since they were designed for. So for pure functions, which just take some results and provides you with output. That's why people are so passionate about functional programming, because they everything is a pure function and they can be easily tested. In PHP, it's not. And for this, unit testing is really should be used for very complex stuff, which can be written in this scenario paradigm. And because algorithm is something which goes beyond this business narrative. So it's really hard to explain in words how our algorithm works. Let's explain it with a test. When we deal with really complicated data like thousands of, let's add a coupon for every 1,000 user of our application. So this is a good scenario for a unit test because you don't want to insert 1,000 users into the database just to the sake of a testing. When we have complicated business logic, so that's another good pattern for unit testing. For everything else, like create user, update user profile, and so on, so everything that which you can test on the database directly, just use integration testing. And the most controversial slides about the mocks, because I've heard lots of complaints about this one. So mocks are dangerous. I think I explained it why. But mocks should be used, really. They should be used, but for this stuff you do not control. You do not own and you do not control. So the database, if it's a local database, you control it and you own it. You don't need to mock it. If it's external database, on the other service, yeah, you probably should mock it. So for third-party services, remote services, if it's network connection, sure, it should be mocked. I think this idea that database should be mocked came to us from Java world because they have external databases everywhere, and yeah, they need to had to mock it. But in PHP world, we always have PHP plus MySQL, PHP plus Postgres. So we work in them in a bound. So we don't need to mock databases for most cases, except we are writing a unit test which have some logic and it doesn't need to go to database for its data. So the rule here is even if you can write a unit test and you feel you can do it, I think maybe integration tests would be more effective for that case. So few words about TDD and not TDD. So TDD approach is very good to start discovering our specifications. So not by writing down these scenarios, but by trying our different code. And for lots of projects, it's really hard because we can't just produce stable, maintainable code. We need to try different hypotheses when the code will finally stabilize, and our tests too. So for TDD, I would recommend you to focus on probably on interface or on controller level, because if the page accepts data from form, it probably will work like that, whatever design you put on it, whatever logic you put on it. So try to work as ATDD from the outer level. And when you have your first failing outer test, you can introduce some logic, some classes into it. And when you see this test passes, you can continue to working on. So it's really hard to choose a proper interface doing the TDD. And then summarizing all the ideas of this talk is, first we need to discover what to test and not what can we test. Yeah. Then we find the way how we can test it effectively. And then we writing readable and stable and I hope fast tests. So thank you.
Thank you, Nickel. We have time for only one question, maybe. If you have more questions, I think you will be available during the entire day for any discussion. So if you have one question or two maximum, please.
Okay, first, thank you for the talk. And do you practice mutation testing?
I think it's out of scope of this talk, so I don't know. I don't know how to fit it in this paradigm. So personally, I don't, but I know people who do, and they're pretty happy about it.
Okay. Thank you.
Anyone else? Okay. Thank you, Michael.